Hello everyone, welcome. So today we will be discussing few questions, and this question is based on elasticity, based on Young's modulus, it is based on stress. So we will be solving few questions which has come to me as doubts. So first question, a metal wire of radius 0.1 centimeter and length 2 meters is extended by a weight of 2.5 kg. Find the normal stress. So what is stress? Stress is nothing but is equal to force per unit area. So now I have to find out force. Force is applied by whom? Force is applied by the weight. So what is force in this case? This is nothing but mass into acceleration. So acceleration in this case is what? It is suspended. So acceleration due to gravity. So m into g. So this is nothing but 2.5 into 9.8. Acceleration due to gravity is 9.8 meter per second square. So this is force. So much Newton would be the force. And next coming to area. What is the area of contact? Area of contact is, if this is the road, then this circle area is the area of contact. So pi r square. So what is pi r square? R is 0.1. 0.1 centimeter to convert into meter divided by 100. So 10 raised to minus 3 meters. So this is 3.14 into 10 raised to minus 3 the whole square. Okay, meters. So this is nothing but 3.14 into 10 raised to minus 6 meters. Fine, meter square rather, area. Fine. Now, what is my stress? Stress. Hence, my stress will be the force that I have, 2.5 into 9.8 divided by the area, 3.14 into 10 raised to minus 6. I will have to solve this particular part. Okay. So, to solve this, you can solve it as it is. I'll just provide you the calculations or the answers rather. Okay. This will come to 7.8 into 10 raised to 6. And what is the unit of stress? Stress is Newton per meter square. So, because I have this force, what is the unit of force? Newton. Area is meter square. Hence, Newton per meter square is the unit of stress. So, this is my first question. Now, let us move to the second question. Okay. The next question states, the ratio of radii of two wires of same material, so R1 by R2 is equal to 2:1, 2 by 1. If the wires are stretched by equal force, find the ratio of the stresses produced by them. Again, what is the stress I said you? Force by unit area, right? Now, they are stretched by unit force. So, if I do stress 1 is equal to force 1 by area 1 and stress 2 is equal to force 2 by area 2. I am already told that force 1 is equal to force 2, right? So, if I do ST1 is to ST2, what will happen? This will become F by A1 is to F by A2. So, force and force will get cancelled, right? If I write this as F by A1 by F by A2 would mean what? F by A1 into A2 by F. Cancel. So this will be nothing but A2 by A1. Area 2 by area 1. So area 2 is what? It is a wire. Hence we know it is circular. Pi R2 square by pi R1 square. So if R2 and R1, it is told, if I have this, then what is happening? In this case, R1 is nothing but 2R and R2 is equal to R in this case. So if I have R2, it is pi R square and this will become what? Pi 2R the whole square. So if you find out, it is pi R square divided by 4 pi R square. Cancel, it is 1 by 4 in the ratio 1 is to 4. So I can say stress 1 is to stress 2 is in the ratio 1 is to 4. Okay. This is the solution. This is the next question. Now coming to the third and the last question of this video. All right. My next question states a force of 1000 newtons causing an increase of the length of 0.1%. The change of length by length is nothing but 0.1% means 0.1 by 100. So this is, if I take it together, it is 10 raised to minus 3. Change in length, again change in length, meter by meter. It has no units. So change in length of the wire of stress S on area of cross section. Area of cross section, what is area? 10 raised to minus 6 meters square. Calculate the Young's modulus. Now, what is Young's modulus? What is Young's modulus? I have the formula as stress by strain. So, what is Young's modulus? If I say stress by strain. Okay, however, you need not be concerned about this symbol, stress by strain. Now, if I say what is stress? Stress is force per unit area. What is strain? Strain is change in length by length. What is the strain that is happening? What is the result I am getting? Change in area by area, change in, what a volume by volume. So that strain, what is happening? That stress by strain. So force per unit area, if I say, this is the force, area is so much. So force, what is force per unit area in this case? Let me take it. 1000 by 10 raised to minus 6. So 10 raised to 3 minus of minus 6, which is 10 raised to 9. So force per unit area is 10 raised to 9 by this change in length that is happening. So this change in length is 10 raised to minus 3. So what is Young's modulus? I have 10 raised to 9 plus 3, 10 raised to 12. 10 raised to 12. So this is the Young's modulus. And what is the unit for Young's modulus? See, force per unit area, if I said this unit is Newton per meter square. And change in length by length has no unit. So what is the unit here? Newton per meter square. The same is the Young's modulus. What is Young's modulus? Stress by strain. So that's it. Thank you.